this is a project to look at the learning effect on lower limb kinetics when single leg hopping in different directions. It's supported by the new faculty research fund from the KU, as well as the summer writing fund from our school. So what we're generally doing is trying to determine how many practice do we need in order to measuring your quadriceps strength or knee functional during clinical settings. So we help participants jump forward, hop backwards, as well as vertically. And what we found is if you're trying to use your vertical jump height to measure your quadriceps strength, you barely need a practice because people are just so good at it. It's so common like daily activities. And if it's a backwards hopping, you may need to employ 5 to 6 each, depending on if the subjects feel comfortable to hop. And for forward hopping, specifically to knee measurement, is not that it's not as great as backwards hopping and vertical hopping, but it's definitely challenging compared to double leg tasks.
Like most of you know, at the University of Kansas within our WellFit Center for Youth Wellness and Fitness, we have a youth strength conditioning program called Jayhawk Performance. And so there's lots of research done on periodization for older adults and older athletes, but there's not a whole lot done with youth in that sense. So what we came up with was a recommendation of physical development looking at the microcycle repetition volume characteristics within our youth program. So the way we did it is we looked at our program that's based off the training systems done by Lloyd and Oliver based on their youth physical development model, and we're trying to add a piece to that with the periodization element of it. So what we did is we broke it down on a week-to-week basis, so from week 1 all the way to week 8, and we quantified the repetition volume, so how many repetitions they were doing on average throughout a week, and then their percent change throughout those 8 weeks from week to week. And so what we found is that for both groups combined, so we have elementary and middle school athletes, and so for both groups combined, we had 180 to 475 repetitions done on a weekly basis. For elementary, we had 120 to 380 repetitions, and then for middle schoolers, we had anywhere from 240 to 570 repetitions over that 8-week period. And then looking at it in our graph way here is we have everything from no change through week to week to a 26%, almost 27 increase, dropping off for week 4, and then a slow build to week 7 up to a 44.44% increase, and then dropping back off to week 8 before our testing week for our post-testing. And so what we found was there is just a development model of using the repetition volume calculations to be able to quantify what our athletes are actually doing that we can also pair in with other aspects of their training.
So for this study, we are looking at neuromuscular strength and power force characteristics of Division I track athletes. We're fortunate enough to have collaborated with the track team on campus, and this is essentially the third installment of a 3-part data collection with the track team. For this study, we're looking at neuromuscular strength and power metrics with the track team by way of trying to find characteristics and what we could find within the first 5 meters of a sprint and how that can correlate to later on throughout a track athlete's sprinting. As we know that initial starting is very important in the sport of track and field, so that is something that we wanted to find and dive into more with the team on campus. So for this data collection, we wanted to incorporate the isometric mid-thigh and counter movement jumps. We wanted to split the cohort into male and female to see if there are any sex differences within the rate of force development of the 50 milliseconds, 100 milliseconds, and so on of the track athletes. So we invited them over to the lab at the JAPL. We had them perform a couple of repetitions of CMJs, counter movement jumps, and a couple repetitions at the isometric mid-thigh pull. We created a ramp protocol to get them into a maximal repetition. And from what we found from our data collection, we found there were significant differences in peak force at 50 milliseconds, peak maximal force, and we were able to find significant differences of braking force and propulsive force, and also along with the net impulse of that 50 millisecond time frame. Jump height did not show any significant differences between male and female, And from this, we can conclude that it is very important to initiate when we have sprinters to have a good initial start into sprinting. But from this group, we were able to see that being males, a traditionally more physically stronger group, we're seeing that they did show some of that initial differences amongst the females. That data can now be translated into the strength and conditioning staff to let them know that maybe some differences or some implications for training might be used on their training days outside of off the track into maybe some strength training. And that with this data set, we were able to collaborate and help them to make those decisions.
Today I'm presenting one of our data sets about vertical jump force time metrics on force plates and 10-meter sprints ability of futsal players. So futsal is not big in the US, but it's the second biggest kicking sport in the world. Small size soccer, basically. Heavier ball in the smaller courts where players have to use a lot of technical ability, tactical movement in order to be successful. And our first attempt is to look at their jump performance and sprinting performance data. And the purpose of this study is to find the relationship, explore the relationship between short distance speed and a force time metric on the force plate. So 22 male futsal players. These are elite players from the European country. And we have them jump on force deck and 10-meter sprints with radar signal for speed. And the results, we found correlation between CMJ, concentric peak velocity, jump height with 10-meter sprints, while others, force time metrics, is not showing any associations. You see the table right here. This is our three significance between concentric peak velocity, concentric peak force, and jump height towards 10-meter speed. So, it's a small set of data, but 22 elite male players is a high percentage of elite populations in this type of study. We hope that our jump data and our sprint data contribute to a bigger data set to set up athletes normative data and benchmark for their development, future development, as well as targeting individualizing training program for the player to improve their performance.
The purpose of this poster was to see if there was any neuromuscular difference between soccer players, D2 female soccer players pre and after and post their competitive season. So what we did is we took 25 competitive soccer players and we put them through a mid-thigh isometric pull, which is basically them just pulling against a immovable object to see how much force they can produce into the ground. And so what we found was that they'll actually improve significantly in short-term kind of force production. So there was a significant difference from force production from 0 to 50 milliseconds and 150 milliseconds, but ultimately peak force was not significantly different. So really what this just tells us is that strength and conditioning works. You should kind of incorporate that into your programming, and that hopefully people, like especially college coaches, can incorporate this into their training.
And my poster is about resistance training volume characteristics by body region with youth athletes. So we kind of observe their upper and lower body volume repetitions for youth athletes in our training program. We divided them into elementary age students and middle school age students. And so we have them complete a variety of exercises, including upper body exercises and lower body exercises. And then each week we quantified how many reps they're doing per exercise. we'd add them together, and then each week we'd vary the exercise volume load. So for elementary students, we increase their volume after the first 2 weeks, and then for middle school, we decrease their volume after the first 2 weeks. And we noticed some strong changes in their strength and performance. And our goal here is really to prioritize form and development, and really familiarize them with the exercises with proper form, so that way when they get to older ages in high school, when they're going to strength classes, they have a better understanding and reduce the risk of injury. So.
This poster is a novel translation of counter movement jump metrics. So it's a metric that I've recently created called the dynamic force, power, and velocity metric, or ratios. And essentially what that does is it helps us translate findings that we see whenever athletes jump, so they're stretch, shorten, and cycle efficiency, essentially. Our goal is to do research so we can have a meaningful impact, right? So this ratio will help us understand how effectively athletes absorb force and how effectively they produce force. And that's true for power and velocity as well, so that way a sport performance coach can create individualized training programs to improve force, power, velocity.
So I actually work with KU football right now as a sports science intern. So we are very interested in monitoring the athlete throughout the competitive season, especially because, as most people know, with football there is very high intense physical demands that are placed on the body, which makes it super important to monitor the training stimulus we're putting on the athlete and how the athlete is responding. So the purpose of my study was to basically evaluate the neuromuscular fatigue throughout a competitive season based off of counter movement jump performance, as well as tying in kind of those external loads or that training stimulus that we're putting on the body. So basically, we did that through using our GPS, or global positioning system units, that you can see kind of right here. And then for the counter movement jump, we use Hawken dynamic force plates, and we do that typically every Monday and Friday. We would jump test the guys, and our sample size was 96 players, just because that's how many catapult units we got. Basically, with the findings of our study, we found that using a repeated measures ANOVA, position group and time of season were significantly different for certain external load metrics, so things such as player load and high speed distance, as well as some of our counter movement jump metrics, so MRSI, which gives us kind of both a output and a strategic metric, found significant differences as well.
Today we're going to talk about some of the kinematics of shooting characteristics of some wheelchair basketballs that's playing Division I wheelchair basketball. So this is a sport that's one of the most popular Paralympic sports. However, there are literally no research talking about this sports, especially within shooting motions. So what we want to note is if there's a difference for experienced wheelchair basketballs, if there's a shooting motion difference between a make shot and a miss shot. So we collected 7 male athletes, of course, from Division I NWBA wheelchair basketball league team, and then we did a standardized warm-up, about 10 minutes, and then we recorded 10 shots for each person at 60 frames per second on a perpendicular angle to capture the 2-dimensional kinematic data. However, since we're working with non-parametric data, we decided to report median and interquartile range instead of mean and standard deviation, and we used the Whitney U test, Whitney U test for detecting significant differences. So over here we have a subject 5 is one of the athletes with a significant difference between make and miss, as well as a subject that's making consistent shots. So are making, but there's no differences between make and miss. So what we can see here is we collected elbow angle, ball height over setting heights, release heights over setting heights, as well as time to release and release angle. None of these metrics has a significant change. However, we can see through the graph the individual with consistent shots has a great consistency and then less variabilities on these metrics. So although we didn't find any significance, you can see in the data, we can see wheelchair basketball players do rely on upper body and trunk joint trunk angles to make their shots. So what we wanted at this stage is to have coach prescribe specific upper body exercises as well as trunk exercises to help the athletes develop a great foundation for their future wheelchair basketball careers.
My poster's over the resistance training composition of youth athletes. So we're looking at kind of their training composition in 4 categories: foundational, muscular power, muscular strength, and speed. And so our goal is just to develop their overall understanding of exercise science and how to perform different exercises. And so we found the composition of each training, so for our foundational, muscular strength, muscular power, and sprinting speed. And we also used the ADP model, so assess, develop, and perform. And so for assessment, our goal is to see their weaknesses and what they could work on to improve. Our develop is to how to develop those weaknesses with training, and then perform is how to use those what they worked on in actual competition.
So for this study, I was fortunate to be a part of with the football team. We had 13 guys with us in preparation for the Big 12 Pro Day this past season. So throughout the 9 weeks, we trained with the team, with a select group of players. We tracked a lot of different things from strength characteristics to agility to speed characteristics. So for this poster and this presentation, I was prioritizing some of the speed characteristics we found from the utilization of our 1080 sprint. We were able to track in our 20-yard sprints. We were able to cut it into 5-yard intervals and then look at some of the differences between position groups at 5-yard intervals. So some of the things we were able to find and some of the significance of what we were able to find is there are significant differences observed in the split times of that 5 to 10 threshold and average speed of that 5 to 10 threshold, along with the split time of that 5 to 10 yard threshold. And we were able to observe no significances were observed in the split times of the 0 to 5 average speed and the 0 to 5 total time. So from this and what we could take home from this is that being Division I athletes, being high-level athletes, that initial 0 to 5 from this, we weren't able to find much significances between the different groups, but as the sprint prolonged, that 5 to 10 threshold range showed to show more of that significance, and we can take that with the strength coaches. We can use that to incorporate recommendations for training regimens and adaptation to try to produce higher sprinting speed to help these athletes do better as these pro days prolong and help to get guys into and perform well at these combines.
Well, today I'm presenting on counter movement jumps for D1 volleyball. We took some counter movement jumps from about 8 different teams in D1 Big Ten volleyball, and we found that for each position there was some significant differences and then there wasn't any. So we found for jump height, they were all pretty much the same, but then we also found that for average propulsive force, which we all thought, your outside, your right side, your hitters would have a big difference, they actually didn't. But the DSs excelled in those, which we kind of chalked up to them being shorter athletes, and your taller athletes don't really need that explosiveness. So we found that really interesting. And
so in this poster, we looked at mesocycle characteristics with youth strength and conditioning. So we wanted to do a recommendation for physical development. So with what we know is from literature, from the youth physical development model, is that we should not train youth athletes like miniature adults. They're their own age group and we should treat them as they are. What there's not a lot of research is on the periodization of mesocycles within a program. So what we wanted to do was quantify our programming, specifically looking at mesocycle to mesocycle changes, average reps and sets done with each mesocycle, and average sets per exercise and average reps per set done within our exercises. And so what we found is was how many sets and repetitions we did within each mesocycle, how they changed from mesocycle to mesocycle, and then the average reps and average sets done in each mesocycle. And so what we want to do with this is present a youth development model that can be paired with the youth physical development model. So for anybody who wants to develop a youth-specific model, they have something to base things off of, which then can help them gauge if they're meeting their specific needs for their group and if they're meeting their specific things that they want to achieve within their training program.
Well, sure. This poster is presenting our findings from a collaborative, normative counter-movement jump project. So within this project, we collaborated with 8 other institutions to serve NCAA Division I female volleyball athletes to better understand not only how high they jump, but actually how they jump. The issue is that there just wasn't enough data from a single team. So we reached out to schools like Louisville, Ohio State, Purdue, and several others to collaborate. This research, we learned, number one, there's power and collaboration. Strength and conditioning research can be improved through collaboration, but we've also learned about the capacity for Division I female volleyball athletes, especially as it relates to muscular power. This information can be taken to improve athletic performance.
All right, so we looked at initial strength changes as well as motor unit behavior change in college-age females. What we did was we had them come to the lab on 2 visits, performed an isometric contraction of the FDI, the first dorsal interosseous muscle, right here. And what we found was that strength did not change between sessions, and there was a change in motor unit firing rates, but no change in amplitudes.
So what's the purpose behind this study?
Purpose behind this study was it was from a larger scale study where we were looking at changes from resistance training of the FDI. So we had people come in, perform isotonic contractions, which we don't normally perform these type of contractions. And
So what was it you kind of learned through this study so far?
We learned there's no change in strength from the first visit to the second, which previous literature has demonstrated there is a change in strength as well as an increase in firing rates, but that is not what we had found. So that is something that I've learned from this.
And we're heavily invested in our athlete monitoring process over at KU Football, and that includes training load management. So for us, it was super important to quantify the training load demands that are occurring during a competitive season, because we want our guys to stay healthy so we can win. So for the purpose of my study was just to quantify what's happening during day 1, day 2, day 3, and day 4 of practice. And we did that looking at different external load metrics using our global positioning systems, or GPS, through Catapult. And what we found was that for day 2 and day 3, that's typically when we were seeing those higher loads, whether that be player load, high speed distance, or a player load per minute. And for us, that's super important within the strength and conditioning staff, understanding that those 2 days are where we accumulate those higher loads. So maybe in the weight room, we kind of modify some of those guys to accustom for that, as well as with our nutrition staff, making sure they're properly fueling for those higher loads and that the ATs are ready for giving guys recovery protocols for those days.
Today we're going to talk about some of the isometric method pool for some data from our Division II golf athletes, female athletes also. So this is a study we captured for some data from isometric method pool test in 2 time periods. One before, during a preseason resistance training program, one before the training program, one after the training program. So we all know golf is one of those pretty popular sports, but collegiate level athletes that does not, we don't have too much research on that population, especially considering the strength and conditioning approach of it. So this is the reason why we did this. And here are some of the metrics we did. Of course, peak force is of interest, as well as some of the force at different time points. as well as impulse and rate of force development, as well as time to peak force, which is important to see how fast they can produce the force. So overall, between the time points from pre and post training session, we do see an increase in peak force. However, we didn't see much of an improvements in rate of force development, as well as impulse metrics. But we do. It is kind of interesting that a lot of these rate of force developments are actually decreasing, which is kind of conflicting with our original hypothesis. But since this is a kind of an exploratory study, as well as these golf athletes, we're still trying to figure out the linkage between isomethyl pool with resistance training, as well as golf specific metrics such as smashing factors, as well as peak hand speed for optimal golf shots. So with that being said, we do want to see a increasing RFD metrics, which is kind of what we hypothesized to correlate well with golf specific metrics. So we do want to see these athletes to take part in a training program that can develop these kind of traits. So what we want to see is they do during preseason, we want them to do a program that focuses on explosive, ballistic, and plyometric exercises that kind of train towards that. And once the foundation is being set, then we can see their muscular strength level to be improving, which helps the coaches to kind of just guide their programs for better muscular strength as well as in-season performance.
So today I'm presenting on the contributions of bat swing metrics to exit velocity in collegiate baseball players. And so the biggest thing is that baseball hitting is very multifaceted movement. And so recent research has found that muscular power in the upper and lower extremities have contributed significantly to various metrics relating to bat swinging, specifically bat speed and ball exit velocity. And so what we wanted to do here was look and identify what things actually contribute to specifically bat swing specific metrics. And so what we did is we used various collegiate baseball players from a few different universities, and we had them swing 10 swings each for maximum ball speed. And so with this, we used a zero-order correlation metrics as well as a forward entry multiple regression to understand what significant contributions led to exit velocity. And so as you can see here in these graphics, there are a few things that really significantly contributed to ball exit velocity. And specifically those, and you can also see here in the results, bat power, on-plane efficiency, connection score, peak hand speed, early connection, and vertical bat angle, as well as time to contact. Those were the things that significantly contributed to bat swing and specifically exit velocity. And so our biggest conclusions here is that, again, those 7 out of 12 metrics contributed significantly to ball exit velocity. And specifically, when it comes to a coaching perspective, understanding these are going to be very important so you can understand areas to focus on for specific athletes when you're trying to maximize that exit velocity. So knowing that these 7 things that are seen here in the results section, if those are the things that are going to really contribute to exit velocity, how can we maximize those? Not also forgetting about other things such as body mechanics, but when we're looking at when the ball is actually going to meet the barrel, what things specifically with the barrel when you're swinging it are going to help maximize either a youth, intermediate or advanced athlete. How can we give them that extra edge to help them get better?
So my name is Benjamin Abel. I just graduated from a Bachelor's of Science in Mechanical Engineering, going into a Master's of Science in Bioengineering. I'm associate with the team at Axial Force here. We work closely with the Jayhawk Performance Lab. So me, along with the team at Axial Force, developed a 3D force monitoring insole. And we decided to go 2 different routes with it, kind of more of a medical side and more of a sports side, for athlete readiness monitoring. So our first test was gait metric detection. We wanted to make sure that we can accurately measure people's gait and be able to apply that to the medical field, specifically more along the Alzheimer's side. And then we also did some 3D force validation for the sports side, doing some athlete readiness, athlete monitoring, training type of things in order to improve forces in the medial lateral, anterior posterior, and the vertical directions. This was essentially the first version of the insole. We're happy with how it turned out, but there's definitely some improvements to be made, mainly in just mechanical components, a lot of fragile components, and just discomfort in the arch of the insole. But we're making some improvements with the next version, and we're really excited about it.